Multivariable functions are great for applications because a lot of times things in the real world depend on multiple inputs. For example, we're looking at a profit function for a hardware manufacturer. We're calling the function f and we're saying the input is x and y. Specifically, x refers to the number of nuts sold per month and y refers to the number of bolts sold per month. Notice that each one of these is measured in thousands. So if x equals 1, that's really like saying 1,000 nuts. And if x equals 0.1, that's saying 1/10 of 1,000. That's like 100 nuts. If x is equal to 0.001, that would look like 1 nut. So in this case, x is allowed to be a fraction because it doesn't represent a single nut, it represents 1,000. So when we look at our domain, we're going to make sure that we only include x values that are larger than 0.001 because it's not reasonable to sell a fraction of a nut, and same for y. It's not reasonable to expect someone to sell a fraction of a bolt. So we know that for the application, our domain has to follow the fact that x and y both must be larger than 0.001. Now let's talk about the range. If I graph the function, we'll be able to see our domain is essentially the positive portion of the xy plane. Now remember, we're not going to let x and y go all the way to 0, but for the scale of this graph, it looks practically like we're including all of the x values 0 and above, and all of the y values 0 and above. And when I plug those values from my domain into my function, I get this red surface, and we can see that the edges of the red surface are directly above the edges of our domain. And when it comes to range, we can see that the largest value of z appears at the top of this upside down paraboloid. And the smallest value of our function, of the output, is going to come from extending x and y to their largest values. So as x and y get very, very large, the function output gets very, very small. So let's take a look at our function. If I let x and y get very, very big, meaning I'm picking points that are very large in x, very large in y, that function output almost looks like 16 minus infinity. So we know that the smallest values of this function would be negative infinity. As for the largest values, that's going to stop right here at the top of the function. And finding that highest point is actually something that we're going to learn how to do in this chapter when we maximize these multivariable functions. But we can notice that the function, as x gets bigger and bigger, eventually it's going to turn into a 3. If x is 3, what's inside of this parentheses is essentially 0. And since we're subtracting that parenthesis term, subtracting 0 means that the output is larger. Same with the y term. As y gets bigger, eventually it'll be equal to 2. When it's equal to 2, that group is equal to 2. So it would be like 16 minus 0 minus 0. So the largest output of our function would be at z equals 16. So we can see that the range goes from negative infinity up to positive 16.